Today we're going to learn how to measure the size of angles in radians rather than degrees. Now let's think about what we know about degrees. 360 degrees makes one full revolution, but where does that actually come from? Well, as our Earth rotates around the Sun, this is the Sun and this is our Earth, it takes 365.25 days or so for us to make one full rotation. So back when people were deciding how they might measure angles, obviously they thought that this was something that was a pretty good number to base it on, but it's a bit of an awkward sort of a number. So I guess they decided to make more of a round number, and they rounded it off to 360. Now, this is a pretty arbitrary way to measure angles. It's sort of loosely based on something, but it ends up being a bit of a random sort of number. So instead, what is a radian? Well, radians are based uniquely on the geometric qualities of a circle. Now let's think about what geometric qualities a circle really has. Well, the most important quality it has, of course, is its radius, because that governs its size, doesn't it? So if we are to measure an angle in radians, it's lovely and simple really. We actually just look at opening out two arms, because when we have an angle it's always made by two arms, isn't it, and how far apart they are. And if we open out two arms and make them both radii of a circle, then the arc length divided by the radius tells us how big the angle is in radians. So this is something that we need to note down as an important definition, if you like, of what a radian is. It's the arc length divided by the radius. Now, what would happen if we took a piece of string that was the length of the radius exactly, and then we started it here and we laid it out along the circumference, and it came to around about here? Well, if the arc length was exactly the same as the length of the radius, what we'd have is radius divided by radius, which would be 1. And that gives us our definition of 1 radian. 1 radian occurs when the arc length is equal to the radius. So that's roughly what I've drawn here, and this is around about the size. Now you might be thinking, well, how big is that in degrees? We'll have a look at how to make the conversions in a moment. For now, you might be thinking, oh, it looks like roughly 1/6 of the circle or so. And that would be a good guess. It's not exactly, but close. Now, let's look at what else we know about circles. We've already learned that circumference equals 2 pi r. We know this. So if we were to make one full revolution of the circle, how big would the arc length actually be? It would be 2 pi r, wouldn't it? So we'd put that in for arc length, 2 pi r. Then we need to divide arc length by the radius to see how big this angle is that is one full revolution. And you'd see here that if we've got 2 pi r over r, we can obviously cancel out both of the r's, and what we get is 2 pi. So using this exact definition of the size of an angle in radians, if we have an angle that is 360 degrees, the arc length will be 2 pi r, and when we divide it by the radius, we get 2 pi. So this gives us what we're basically going to use from now on as our main conversion. So we should put this in a box. It's nice and important. 360 degrees, which we know is one full revolution, is 2 pi radians. Now, radians are so central to the nature of circles and angles that in fact we can actually leave the label off. Although for degrees we need to have this little degrees symbol, and it's not wrong to write 2 pi radians, we can actually refer to the size of angles just as, say, 2 pi or 1. Here, if we had this being equal to the radius, then we would say, how big is this angle? You could say 1 radian, but you could also just say it is 1. And this ability to leave the units off is quite unusual. You've probably never measured anything and left the units off. But with radians we can.